All right, it's like 2 past the hour. Welcome again, everyone, to our workshop today. It's about data engineering. My name is Frank. I work for Databricks in the tech marketing department, and I'm joined by a number of colleagues today. And let me bring up that slide. It's ladies first, Pamela, and then we have in alphabetical order, Dustin, Harsha, and Mohan. And all I can say, you guys are super lucky to get today because these are our subject matter experts, and they're going to assist in this workshop. They're going to answer your questions. And it's really the most knowledgeable people we have. It's the kind of people I go to if I have questions. That's why I said you're super lucky. Please be mindful. We talk about data engineering, so be mindful with the topic. Don't throw all kind of questions at them. So if you do something completely different, this is about data engineering. We talk about orchestration. We talk about pipelines. We talk about AI a little bit. And those 4 people will support the whole event. Now, this event is a hands-on workshop. That means you will be working hands-on in an environment that we provide for you. It's actually a Cloud Labs environment, and you connect to it using your browser. There is a link to sign up for this environment, which will be shared right now, I guess. Some of you already might have that link, and you use that link and connect, sign up for that environment, and then connect to the environment. And you see the thing that is written here in green letters. It says incognito window. And that's actually the most important thing. Open an incognito window in your browser and then connect to the environment. Most of the issues that we see, they actually come from people not doing that. So to save you time, to save you trouble, to make this a much more pleasant experience for both for you and for us, please use an incognito window. I can't say this often enough. And then we also shared some lab guides with you, or we will share them again. Don't worry if you don't have them yet. Don't start now with these labs. So the idea is I'll talk about what we cover first. Then I even show you what we do. I'll kind of do it myself, and then you'll get some time to do it yourself. So it's not the idea that you run off now and start doing the labs. So please listen first and then follow the lab guide. It's like a rough step-by-step instructions that you can use all the time. We're going to work with a GitHub repo, actually with a folder in a GitHub repo. It's on that slide. Don't need to write it down either. It's also shared in the chat with you. And we're going to share it later with you again. So it's a GitHub repo. It basically says github.com/databricks/tmm. And in this repo, we only need a folder. Don't worry, I'm going to show you how you only get that folder from within the repo. So that's all things we do hands-on when we start with the hands-on labs. Before we start with the hands-on labs, I thought I'll set the stage. I'll explain a little bit of the context, what we're doing. Quite often we get like 80% of the people who say like, wow, I've never used Databricks, or I only used it a little bit. So I think it makes sense to make sure we all understand about, all understand what we're talking about. And if you have the link to sign up for your environment, it kind of looks like this. You need to provide your data, you click on submit, and then you get a link to connect. And remember, use the incognito window to connect to this instance, and then it should work. Incognito window. Do you want me to say it again? I'm not saying it again. Incognito window. All right. Okay. So I guess everyone here has played with GPT. So there's a lot of talking about, AI, Gen AI these days. And there's actually always makes me laugh. There's also kind of people think they could build a business on top of, GPT and have a nice, like, simple front end and then just forward it to GPT. And if you think about this, this is not going to work. It's kind of like making your money with Googling stuff. So GPT, or access to this general LLM, is kind of a commodity these days. So all the 12, 13-year-olds, they use it to do their homework. If they already use it, you will not make like a really good business out of that. It's like making business out of Googling for stuff. So the difference is like these LLMs, they're trained with all the data on the internet, and you can ask them all kind of questions, which is nice for, doing your homework. But what most people want to do here, and this is why they're here, is they have their own data and they need information about their own data. So they want to have AI that is working with their own data. So it's not so much the general intelligence, but it's the data intelligence. And this is what we want to cover here a little bit. And if you think about this, if you want to do this, you also need a platform for that, because you have platforms for your data. I guess everyone here has data platforms. Sometimes it's plural, it's really data platforms. And some people, they also maybe have a lakehouse already. And that's like the core architecture that we should have a quick look at. And Databricks pioneered this lakehouse architecture, this lakehouse platform. I like to see it really as an architecture style. And this architecture style at the core means you kind of get the best of both worlds. You get the best of a data lake and you get the best of a data warehouse, but it's one unified multi-cloud platform. And this is what we call the lakehouse. If you Google around, it's like Databricks pioneered it, but if you Google around, like all the big vendors, like all the big cloud vendors and all the database vendors, they talk about the lakehouse platform now, which is good. I mean, that's like just, it's adding to the trend, and a lot of people want to see these benefits that they get from the lakehouse platform. Now, if we zoom in a little bit, can't zoom in here, but I can highlight this for you. So if we highlight this, it kind of starts at the bottom layer with an open data format. And maybe some of you know, we also pioneered Delta or Delta.io. If you go to Delta.io on the internet, you get to the open source GitHub repo for this open format. And it's not only Delta Lake, it's also Hoodie and Iceberg, and all this is kind of unified under Delta uniform. So there's a common open source format, which is kind of encompassing all the standards that we see these days. And if you want, you can use this purely as open source, but a lot of people, obviously, they want to have the managed platform, the full stack. Now, this very bottom layer is just the lowest layer. It's just getting access to your data, having asset transactions, having versioning, having rollbacks, having clone functionality on top of your data lake, and making your data lake looking more like a data warehouse, giving it the quality of service criteria or capabilities from a data warehouse. But we need more. What we need is some governance layer, and that's called Unity Catalog. That's the product. That's a real product. We're going to talk about Unity Catalog. And when I told you the lakehouse kind of merges the best of data lakes and data warehouses, Unity Catalog does the same thing. It needs to work with tables, and it needs to work with volumes and files and all this. And this is also what we're going to cover a little bit in this workshop. And then we have the workloads on top of this. And obviously here we're most interested in ETL, that's Delta Live Tables. And we're also most interested in workflows. This is what we use for orchestration. So that's a rough view of what we're going to do today. And that's the core platform, and remember, I talked to you about, that's the lakehouse, but then I also told you about the Gen AI things that everyone wants to do. So we need something that kind of has both, we want lakehouse plus generative AI, and that's what we call the data intelligence platform. And don't worry, I'm not going to show you a whole new architecture diagram with a new stack. The thing that changes from the previous architecture diagram is this data intelligence engine in the middle. So there's some component in the lakehouse that turns the lakehouse into this data intelligence platform. It's actually just it's this layer. It's not a product. It doesn't have a UI. You don't need to worry about it. A lot of these things, they just happen behind the curtains. And we're going to see this, and we're going to work with this as well. So it's a data intelligence platform, which is this additional stack that kind of turns the lakehouse into the data intelligence platform. So basically, we can say the Databricks intelligence platform, it provides the foundation of all the data engineering in this age of AI that we see today. And if you think about it, it's actually going in both ways. Some people, they really want to see this whole chain of how do we ingest data, how we transform it, how do we make sure it's clean data, it's you know, it doesn't have like entries that we shouldn't see. And then how do we feed this data maybe into a vector database? And then from the vector database, how do we create models or RAG applications? So it's all this data engineering that we need to do for AI. That's one side of seeing it. But then having all these AI-based tools, it's also valid to ask the question the other way around. So how does the Gen AI movement help us in data engineering? So there is improvements in tools, and part of this workshop is also showing you these improvements. And I'm going to tell you right away, it will be Databricks Assistant that is giving you a lot of additional capabilities as a data engineer these days, but there is also more, and we cover this as well. So it's data engineering for AI, but it's also AI for data engineering. Works both ways. Now, going one step back, talking about data engineering. What's the rough overview, like a 10K overview from a 10K flight for data engineering? Well, we have data sources on the left-hand side. We have the platform in the middle. We need to ingest data from these data sources. And those data sources, it could be an S3 bucket, you know, it could be a PubSub queue from Google Cloud, or it could be an Oracle database, or it could be an enterprise application such as Salesforce. All these data sources exist today. And if you run your own enterprise, you know, you probably don't have 4, but you might have many, many more. So there's a multitude of these data sources. And then with the platform, what we do, we ingest, we transform, we orchestrate. Sometimes this is real time, and we talk about streaming data. Sometimes this is batch. We can do both, but it's always this ingestion, transformation, orchestration. And usually people tend towards, you know, go to streaming data. They want to have fresh data. It's always better if you act on fresh data, depending on your use case. But this is like both are possible. And then at the end, on the right-hand side, we have these use cases, analytics. We want to have ML apps. We want to have real-time applications, or we want to do data sharing. So this is like the rough overview of what is possible with a platform, and also kind of what we covered today. I told you about orchestration, and if we speak about orchestration, it means we want to orchestrate, you know, any number of tasks, of different tasks in a kind of workflow. And the product is actually also called Databricks Workflows. This makes it very easy. It's a super easy, simple authoring experience. If I show you this later, it's basically you create a workflow, you right-click, you define those tasks, you put them together, and then you run the whole thing. And this is one of the goals that I want to achieve with you. We start with the pipelines. We start with data flow, but then we talk about control flow, and control flow is orchestration. And this is what we do with Databricks Workflows. And it's an amazing tool. It just is there. It exists in the Lakehouse. You don't have to install it. You don't have to configure it. It's just running. It's always there. It has a super high availability. We operate it for you. It's a managed service. And what you do is you pick one of the things that you want to orchestrate. We like to call them tasks. So you pick one of these tasks from the front, from this upper row. Could be a notebook, like we like to orchestrate notebooks. It could be a dashboard that you want to refresh, or it could be a DBT project, or like, you know, some Python wheel, whatever. So you pick one of these, or like several of these. You tell us like, what is the order? Should it be one after the other, sequential? Do you want to do this in parallel? Or do you even want to loop over like a number of items and define the concurrency that would be this for each loop? So you pick the task, you define the control flow, how it should be executed. And then you tell Workflow how it should be triggered. You want to trigger it manually. This is actually what we do a lot in this workshop, because once we defined it, we want to run it. So we just push the button. It's this manual trigger. But it could be done based on APIs. So sometimes companies have existing workflow systems, and they want to use them to trigger Databricks workflow. You can do this based on a file arriving, or you can do this based on a table update, or you can just make sure such a workflow is running continuously. So that's like super easy, and we're going to try this later. I actually want every one of you to run a simple workflow. The other thing is delta life tables, and delta life tables is the way Databricks thinks you should do data pipelines. It's a data pipeline tool. It's data flow, and it allows you to define your data pipeline in simple SQL. You could do it in Python as well. I'm going to show you some Python code just in, I think, the next slide. But actually, most of the pipelines that I've done like in the last year, they were all done in SQL. So it's like very convenient for someone who has analytics experience and wants to do more data pipelines. You can do really complex data pipelines in SQL these days. The core thing, it's accelerating your development. We run all the infrastructure in the background. So you don't need to think about like how big should that cluster be for a pipeline, because that's actually a very hard question to size a cluster accordingly. And the thing is, once you've sized it accordingly, it just might change within 10 seconds because your load changes. And maybe you work with streaming data, DLT supporting streaming data. There's a peak of, new events coming from an IoT system, and you need to redo this scaling again if you do it manually. But the thing is, DLT does it for you. And these days, it's even running serverless. So there's this automatic scaling. You don't even think about clusters anymore. You have confidence in your data because we give you those constructs that allow you to define constraints. And with these constraints, you make sure that that bad data is not flowing into your tables. And it works for batch and streaming. So that's DLT. And then sometimes people say, well, Frank, you show us these medium-sized examples, but does it really work for the big things? And this is why I always bring you in this slide. So this is one of my favorite blogs. A number of colleagues of mine, they were running a test, actually a benchmark test. And to run that benchmark test, they ingested 1 billion records. And the total amount of money, if you do the math, it cost them less than $1. So 1 billion records for $1. And that's like one of the cool findings of this blog posting. But the other one is, and I'm going to share these slides with you later, and we're going to mail them to you. We're also going to mail to you the recording of the session. So you get the slides, get the recording. We keep the GitHub. It will be up all the time, so you can reuse it all the time. Let me click on this link, and that's the online blog posting. And what I wanted to do is actually not go into the details about this benchmark, but implementing this benchmark. Look at what they did. It's hard to see because it's so tiny, and every box with this green top layer is one table. So it could be incredibly complicated. Sometimes people actually even programmatically construct this stack, this mesh of how are those tables interconnected. That's possible. That's one of the reasons why sometimes people are not using, why sometimes people are not using the SQL version of DLT, but they want to have this meta programming with DLT, and then they go for Python. But that's all future music. We want to cover the basics here, and this is why I go back to my slide. Remember, billion records for less than $1. That's incredibly cheap. And yeah, so what are you doing if you, I think I skipped one slide. Yeah, that one. What are you doing if you work with DLT? You actually need to know two components. One are streaming tables, and streaming tables, they're used for ingestion. You ingest data. It's actually ingesting data exactly once. So we keep track of, what is already ingested, and it's for append-only sources. So if you have data in a S3 bucket, like what you see here in this top code snippet, like reading from S3 some bucket and you add more data, the data that was read already is not read again. So there's a very clever system of making sure that you read this exactly once. So it's a simplified way, it's a simplified table to ingest and process streaming data. It is streaming data, so it also could read from PubSub, it could read from Pulsar, it could read from Kafka, and here's the code example from Kafka. You see, this is still SQL, but within SQL, we have this function that allows us to just read from Kafka. I'm going to show you a super cool use case later, just a pointer to a super cool use case, but this is not a possibility. Okay, so it's ingestion, it's streaming data. You can do operations, but sometimes they're not like super complex. For streaming data, there's a limited set of transformations of operations that you can do. It's append only, so you can't change existing data. You can update these SQL statements. That's possible, and that's the streaming table. Remember, streaming table, ingestion, incremental ingestion. That means we read the data exactly once. Okay. And the second one is a materialized view. Most people, they know materialized views already. And that's good because you define a view, it's a materialized view. That means it's pre-computed. If you access, let's say, the data in this materialized view, you get this very quickly. This is why these materialized views, they're very often used for dashboards. So if you have a dashboard that is like, every minute going to this materialized view, it doesn't need to be computed. It's kind of pre-computed. It can just be reused. So it is excellent for dashboards. It's great for complex joins, aggregations. Whenever you want to use something downstream, people often turn this into such a materialized view. So remember, streaming tables, ST for ingestion, they come first, and then typically at the end, you see this materialized view, and they kind of offer data for downstream usage. Not that complicated. It's pipelines consist of STs and MVs. That's maybe the main core takeaway. And then, of course, I told you can link them together. That's what I told you, streaming tables on the left-hand side. This is where we ingest the data. Two different tables in one pipeline. Obviously, we can ingest from two different sources shown here, and then we have two different streaming tables. And then in the next step, we combine them, we join them in a clever way. It's a materialized view. And then maybe we make this we kind of narrow this even more down, and we have a materialized view, which might be the daily orders materialized view for a dashboard with the same name, daily orders. So it's streaming data pipeline for fresh data. It works for streaming. We kind of concatenate these streaming tables and materialized views. Here you see these three layers. We like to talk about the medallion architecture, which basically means if you go from bronze to silver to gold, the data quality increases. So the kind of best practice for the bronze layer is just ingest the data. Don't do any fancy transformations that could go wrong. Just make sure the data gets off some message queue like Kafka, where it expires like in 7 days, but you don't want to lose your data. Get it off Kafka, get it into this bronze layer, and then you have it there. It's like a data warehouse. You won't lose your data. No complex transformations. Here you see the joins, and then here you see data, which is even more prepared for the downstream dashboards. So streaming tables at the beginning, materialized views at the end. This is what a pipeline consists of. You can read from several data sources at the same time in one pipeline. And this is exactly what we're going to do in the lab. This is the example I told you. It could be Python. It doesn't have to be SQL. That's actually one of the examples. Like if you heard a similar workshop, like, I don't know, it was like 18 months ago, I would have told you, look, if you want to read from one of these message buses, you have to go to Python. These days, it's not true anymore. I already told you how it works. There is even in SQL, there's a table valued function. It's called a function that just says read Kafka. And from SQL, you can very conveniently read your Kafka data. You obviously specify the same The same parameters you need to say, you know, which broker you want to connect and what's the topic that you want to read from. But all this doesn't have to be Python anymore. If you prefer Python, you can do it. It's your choice. You know, sometimes people, they code everything in Python and they just have the tools and they feel more comfortable. And yeah, you can choose. We want to give you choice, and this is easily possible. But it's not a must anymore that if you want to read from such a message broker, you have to go to Python. That used to be a while ago, but it has changed since at least a year. All right, and then another super cool thing that is like available throughout the Lakehouse or throughout the data intelligence platform is this concept of serverless compute. As you know, Spark is kind of tightly linked to clusters. So what we have now is serverless compute. We had it for a long time with DB-SQL. So that's the kind of, say, the data warehouse part of the Lakehouse, where we give you the SQL editors with the syntax highlighting and the code completion, and where you define your queries and dashboards and stuff. And this was the first, let's say, workload where we had serverless, and now we have it for workflows and notebooks and Delta Live tables. And that's what everyone wants to point out. But a lot of people forget that also many other things, actually almost, I think everything in the Lakehouse is serverless these days. So if you need a vector database for RAG, it's serverless. If you do Unity Catalog, it's serverless. Show me one thing that still needs a server. So the whole Lakehouse, I say, is serverless. And that's a big benefit because serverless takes away the cluster. So all the cluster configuration settings, they go away. No knobs. It is very efficient because we scale it for you. We manage those instances that kind of exist in a warm pool. We dynamically assign them and also take them away. And that means also you pay less because you pay only according to the load that your workflow is creating, and it is more reliable. Now, people say, "Hey, why would that be more reliable than a cluster?" The answer is a lot of people, you know, they do weird things with clusters and they set weird settings, and all these knobs, they go away. Look at this first line. I think it's, oops. It's here, no knobs. So the serverless, you just set it to serverless and it works. And this is why at the end, it becomes more reliable. So we have this for workflows. It improves the startup time. It's typically less than 60 seconds. If you want to know about the cost, there's something which is called system table. It's a delta table. You can look up the cost. We have the same thing for notebooks. I'm going to show you a notebook. We all want to play. I say play, but actually it's hard work. It's working with a notebook, finding a bug in a notebook, and that notebook will be using serverless. And your challenge will be to find a bug in a line of code that doesn't look as crazy as this one, but it's sufficiently complicated. And also these notebooks, they run with serverless. Typical startup times less than 5 seconds. And then you say, okay, but how about the pipelines? Also the pipelines, it's one tick mark. I absolutely love it. You set this tick mark, and then all your thoughts about cluster and compute are gone. Actually, if you remove that tick mark, we still have the section. That would be the old way of doing this, the section for compute. And you can set like what's the min and max compute and what settings do you want to use, etc. All this is going away. One cool thing, it does vertical auto scaling. So we scale the cluster. If we think about auto scaling, and if you have such an ops background and you think about scaling, typically we think about horizontal scaling. You know, it's adding more boxes to a cluster, and this is the way to scale a cluster. But sometimes it doesn't really it's not the best idea to add more compute nodes to a cluster. Sometimes the workload has a memory issue, so it runs into memory problems. And if we detect this, we don't add another box, but we give you a bigger box with more memory. So this is the way vertical auto scaling works. And if you had to figure this out yourself for any given workload, what is the best way to scale it? It's almost impossible because it could change every 10 seconds. And we do this automatically. I told you about these MVs. Maybe that's the core takeaway. If you have materialized views and you do serverless, they're also refreshed incrementally, those MVs. So they're not recomputed if the computation needs to be done. If you have like 1 billion rows in an MV and there's like 3 new rows kind of coming, it's not recomputing 1 billion plus 3 rows, but only adding those 3 rows. This is like how you should think about it. Because it's so new, there is a promotion going on until October 31st. You basically get 50% discount. It's automatically applied to your workload. So if you want to try serverless, this is the very, very best time to do it now. Yeah, thinking about this discount, I think it's workflows, DLT, notebooks. It doesn't apply to SQL serverless because that's like existing since longer time. Then one more thing, and I mean, this came up in the last workshops, people say, is I got this question, someone said, hey, you always talk about ingestion. Is all the work of a data engineer ingestion? And I was like, no, you should have like, you should think about 3 different things. One is ingestion, and this is what we cover intensively here, because that's the bread and butter. That's what you do all the time as a data engineer. You need to ingest from different data sources and make sure the data lands in the lakehouse. But sometimes you don't want to ingest the data. You just want to access the data. It's more integrating existing data sources without copying over the data. Maybe because you don't want to, maybe because you can't, maybe because you think it doesn't make any sense. So this is more data integration, and we call this lakehouse federation. So in the lakehouse, you can use federation that allows you to access your existing databases, etc. So that's one other way of doing it. And then the third big category that we don't emphasize enough, and it's like an amazing technology, and I just used to work with this, is data sharing. So you can easily share data between workspaces. You can also share data from a Databricks workspace to something completely different. The technology is called data sharing, and it's taken over widely now by the industry. I just read an article like Oracle data warehouses, they use data sharing, open source data sharing, to share their data with the world. So I think as a data engineer, think about ingestion, think about integration with Lakehouse Federation, and think about data sharing, and then break it down to the products that you want to use. Here, we talk about ingestion almost all the time. Just wanted to give you this extra slide. All right, and then some of you, they have been at Data and AI Summit. And this is actually, Mike, this is the call out for the poll that we want to run at Data and AI Summit. In the keynote, Bilal, one of our engineering PMs, he kind of gave the very first demo about Lakeflow. Lakeflow is basically what I just told you on one canvas. So it's workflows and it is data pipelines together on one canvas. That's Lakeflow. At Data and AI Summit, you also saw the first demo. If you get the slides, you just click on this Lakeflow demo. It's in our demo center. So databricks.com/demos is the demo center. If you click on that big red link, I'm not doing it now because you can do that later. You get to the Lakeflow demo. And it kind of includes ingest, transform, orchestrate, and it kind of combines workflows and DLT on one canvas. So that's Lakeflow. Mike is running the poll. If you have been looking at a demo, if you are working with DLT and workflows, let us know your opinion. Like, what do you expect from Lakeflow? What's your #1 priority that you want to see in Lakeflow? I'm super curious to hear what you're saying. And with this is the very last slide I want to show you. I hope you're all connected. I would say we do like a 2-minute break. So I can catch some air. You can kind of maybe grab some coffee, and then we start with the labs. So if you're not connected to your lab instance now, this is a good time to do it. Maybe it's also a good time to reshare the link that people need to sign up to get their lab instances. Once you signed up, you get the URL to connect and a username and password. And that's what you should do. And then once you are connected, you should have something like, this is the data pipeline that we are going to build together. So you've seen the result already, but you should have something like a workspace. And let me see, at the beginning, it looks like this. It says, welcome to Databricks. So if you get there, it's fantastic. All right. We are starting with the labs, and you should have a lab guide already. If not, just check the chat again. We shared, I think we shared it in the link. We probably also sent you an email. If you still don't have it, you will have it after you created your GitHub repo. And that's the first step that we do. And in that GitHub repo, actually, in that folder that you check out from our GitHub, there is also a lab guide. There are some notebooks that we use to work with, like one is, for example, containing that pipeline. But there's also a notebook, which is like the online version of the lab guide. So either way, once you have that folder, you also have an electronic version of the lab guide, and you're set up for the future. Let me move this a tiny bit. Okay. All right. So the first thing to do is, there's actually two things we need to remember. One is in the lab guide, we start to talk about you should do sometimes things where you specify a name. Now, if we are like 1,000 people, and I'm just guessing now, sometimes we are more than 1,000 people, and you all specify the same name, and we all work with the same Unity catalog, which you see here. Here it says catalog, and that's the front end to the governance system. And in this governance system, there is a catalog, which is demo, which is what we're using here for the lab. And then in this catalog, we're going to create different schemas. And I created one for myself already. That's the Frank one. But if you all create schemas here, you all use the same name because this is a shared environment, well, it conflicts and nobody knows, which one is which. And we have these issues. And this is why sometimes in this lab guide, it says, please use your user ID. And now you say, okay, where is my user ID? And the answer is, this is what you see if you click here. If you click here, top right, it says ODL user, and it's this user underscore and that number. And that is unique because it's your login. And whenever it says, please use your user ID, and that's typically for pipeline names, that's for schema names, like here, the ID is just put user and this number. You can copy it from here. And that's the thing I wanted to explain. And then you should be able to find it again. All right. Okay. So step number one is we need to get hold of this GitHub repo. And to do this, I'll go away from this catalog thing. I'll click on Workspace. In Workspace, just click on Home to make sure you're in your home directory. I say home directory as if it was a PC. It is not really PC. It's the Databricks data intelligence platform. And then in this, if you click here, you're on Home. You can go to the right-hand side. You go to Create, and then you say Create Git folder. And this is where you need to specify the Git folder that we want to create. So it's based on a URL, on a GitHub repo. And we shared this URL in the chat, and it's also in the lab guide. And I'm also going to show you again. I have it here in the bookmarks, most likely. It's this one. Yeah. So it's TMM Pipelines Workshop, and the full name is this one. And the ask is you put this here. It's databricks.com TMM. And if you do this, like github.com databricks/TMM, it automatically detects it's GitHub. That's not difficult because it says here it's GitHub. It automatically takes this folder name. I just recommend keep that folder name. And then we say sparse checkout because we only want one folder. And also this extra folder, we give it to you. It's in the lab guide. It's also shared again. And then, where am I? I'm here. I'll put this here, this folder name. And the important thing is put that tick mark on sparse checkout mode. And then it's this cone pattern. It's not clone, it's cone. I always thought it's a typo. It's actually cone. It's the folder that you want to check out. Now, I've done that already. I have this already. But if you click on create Git folder, it's going to take that Git folder from that repo, and it's going to create a TMM folder. And in the TMM folder, you get this Pipelines Workshop folder. So get that URL, get that name of the folder that we want to have, and then don't forget to put this tick mark. If you don't put it, you get the whole GitHub that we have that we use for many different workshops. It's probably more than you want to see. It's not a secret. It's public GitHub repo. And this is not going away. That's also something I want to reemphasize. If you like this lab a lot, if you feel like you're super confident now, you want to redo this with a group of 10 people in your enterprise, you're more than welcome to do so. Actually, the only thing I ask you is drop me an email, because we really love to hear from you if you're reusing that, just because we're curious and want to see if that makes sense, what we're doing here with you. So get that URL, this fills out automatically, this comes automatically, put in the folder that we want to check out, click on create Git folder, and then it looks like this. It starts with this folder name, and then in this, you see this Pipelines Workshop. And then in the Pipelines Workshop, you get what I promised you, you get the lab guide. So if you double click on the lab guide will open. And I am actually less interested in the lab guide. Maybe I give you 1 minute to catch up and make sure you all have this structure like TMM Pipelines Workshop. Yeah, just 1 minute. And then if you click on that Pipelines Workshop folder, you should see these notebooks. And the very first one I want to work with is obviously the DLT one. You're all getting there, hopefully. Okay, I'll click on that name on the DLT folder and click this away. And this is the pipeline that we want to build. Remember, I told you such a pipeline consists of streaming tables and materialized views. And if I scroll down, you see the SQL definition of the first streaming table. It says create streaming table. It has a name, like this is the name of that streaming table. It has a comment because, we want to be user-friendly. We give comments so other people understand what we wrote. You can leave that comment out. But here we have a comment. And then it says, well, create that streaming table with that name as, and then like, how do we create it? And the answer is, well, just take everything from this volume. Now, this volume is an entity. It's a volume, like a file volume. It's a file system. And this is managed with Unity Catalog. So I told you we work a lot back and forth with Unity Catalog. And if I change and go to Catalog here, and I click on my catalog, which is the demo catalog, and then I click on Loan IO, you see these volumes. So there's like 3 volumes defined, and one is for historical loans, one is for transactions, and one is for accounting. And this already tells you that we have a finance application. So what is happening right now, we have a loan broker. So many people are requesting for loans, and there's this loan broker running. I'm running that for you. That's the service that I provide, except talking. So this is running in the background, and your challenge as a new data engineer is integrate with this loan broker, ingest the data coming from this loan broker. And the whole thing, if you draw it, it looks like this. There's different inputs coming. There's different data sources. So we need to have like 3 different streaming tables. And then we aggregate these streaming tables in the silver layer. And then we refine them again for this gold layer. And that's all you need to do. Now, luckily, I brought you that code already. So we're basically looking at the code for this layer, and then the code for this layer, and then the code for this layer. And you remember I told you with the PowerPoint slides, ingestion is done with streaming tables. That's how we create a streaming table. If you're a database person, you would say, come on, Frank, this is nothing new. This is a CTAS statement. Create table as select, CTAS. And it's always the same pattern, you know, it's not like you need to remember crazy things. It's CTAS, create table as statement. Now this data, it's coming from that volume. The volume, well, it's part of the loan broker. So I set this up for you. You don't have to worry about this thing. It's the backend system that you need to access. And this backend system is writing data to this volume. And this is where we read it from. It's JSON data. It has a certain structure. And cloud files is the magic keyword to read from this volume. It's reading in a streaming way. So that means the streaming way says it's incremental reading and it's reading the data exactly once. So all this complexity of incremental reading exactly once is done by the system. And cloud files is more the syntax way of defining this, but the product behind is called autoloader. 2 words, autoloader. And with autoloader, we ingest from S3 buckets, for example, or from volumes. This is what autoloader does. And to use autoloader here, we say cloud files. Now, this is the first streaming table, like one of these. And this is reading from a volume. The second one is reading a delta table, which is also stored in this volume. And it's the same pattern, CTAS. It's actually a materialized view. And now some people say, oh, Frank, you told us that at the beginning we always have these streaming tables. Well, I should have said usually always, because this materialized view, it's not really streaming. It is a reference table. And later, if we have the pipeline running, you will see there's just reference entries that we use to cross-link to other tables. And I can tell you there's exactly 6 of them. There will never be 7. There will never be 5. It's like a fixed thing that we reuse, we read all the time. And then you remember, well, fast reading, fast reviews could be for dashboard. Here it's a materialized view. And this is just to tell you, you know, it's not everything etched in stone. I could change this to streaming table. It would work the same way. I just took this, you know, to teach you there could be exceptions. But the third one, streaming table again, it is reading select stuff from cloud files. You already know this is autoloader. Then next layer is the silver layer. If we look at the silver layer, again, it's a streaming table. Again, it's a streaming table. It uses constraints. If you look at this, so there's a constraint that says the payment should be this year. And the way to define this constraint is we use expectations. We say we expect, and then we have the next payment date should be older than this. So with these constraints, we guarantee the data quality. Actually, data quality, sometimes just heard this, you know, someone in marketing saying, data quality is constraints. It is more complex than this. You know, you have data quality guaranteed by the lowest layer, by Delta Lake, by Delta IO, because of the ACID transactions. This is what guarantees, you know, the lowest layer. We have data quality that we have here with this kind of syntax definition that we define expectations. And then we also have data quality on an architectural level. If we think about this bronze, silver, and gold in the medallion architecture, that's also a way to increase the data quality. So it's not as easy as this, but the takeaway here for DLT is expectations. We define them. And then you also define what happens if they are met or not met. Actually, you can drop a row, you can fail the update, or you can don't specify anything, and it's just logging what happened. So this is the way we define the whole pipeline. And then let me scroll down at the very end. This is a screenshot. It could be a dashboard. Typically at the end, I told you we have these materialized views. And this is doing a select and a group by. And the same thing happens here. And there's another one which is actually doing a union. So it could be more complex operations. Once you have this, and you already have this because you have it in your folder, in your GitHub folder, you say, okay, now that's the code, but now how can you get to the running pipeline, you know? And the answer is, well, you need to run that pipeline. And to run that pipeline, you need to define it as a pipeline. You go to Delta Live Tables. You see mine is already defined. So I'm going to show you this. And since mine is running, I can already see this graph, and you see how many data, how many rows are ingested, and you see all this graph that is actually derived from the code, from the SQL code. But how do you get there? Well, you need to click on Delta Live Tables, and then you click on Create Pipeline. This is to create your own pipeline from the code. You give it a name. Now, this name, again, please use your user ID. So it would be user underscore, and then you type in the number that you see on the top right. I'm using this because I won't save it. Just want to show you. Then remember, we do serverless. Why not doing serverless? If we don't do serverless here, and I scroll down, you have all these compute settings, cluster policies, scaling from, to, blah, blah, blah. We don't really care about this. I want to see a running pipeline. I click serverless. If I scroll down again, all these compute settings are gone. Then next thing you need to decide, is it a triggered pipeline or does it keep running continuously? Now you say, how should I know? The answer is the data is coming in continuously, but you can still have a triggered pipeline. And that's extremely cool. So the triggered pipeline, it would be triggered. Well, actually, first of all, because you click on one button and then you say, okay, what happens then? It reads all the data that is available. It does all the processing like ingestion, transformation, etc. And then it stops. And then if you trigger it again, it will read incrementally the data that was added. You say, okay, but that sounds more like, who's going to use that in production? The answer is, well, in production, you're not clicking on that button to start the pipeline. In production, such a triggered pipeline would be triggered, well, by an orchestration system. And then we trigger it with workflows, and you can trigger it to run every 10 minutes, every Friday at 4:30 before you go home, or you can use all these other triggers that we have in workflows. Okay, we stay with triggered, we stay with serverless. You please put in your user ID. Then we need a path, and as I click on this icon, and then the thing is, don't go to repos, go to users here, go to your username, then go to TMM, remember that's what we checked out, go to Pipelines Workshop, and then use the 01 pipeline SQL. That's the one, that's the source code. Click on select. You see I could add more source code. That's very interesting. I could define a pipeline in a single file, or if it becomes more complex, I could even define a single pipeline in multiple files. That's also possible. And I'm not doing this. We have the whole pipeline in this single file. So specify your pipeline. Make sure you get to the 01 SQL code. Storage options. I already told you this. I went to the catalog. Remember? Demo is the name of the catalog. And then it says target schema. And oh, la, 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 la. What's happening here? Who created all these schemas? That's you guys out there. We need a target schema. Take the username like your user, and then take your number like whatever your number is, and it will be created for you. And let me show you something cool if I find it. You say, I told you it's the catalog. I told you it's part of Unity catalog. But the thing is, like, who is doing what? It looks like this. That's actually what is happening. And this is the way I set up Unity catalog. So I defined this catalog. I said it's called demo. And then I defined a schema that we are going to use for the volumes, which are called lone.io. And then I want you to create your own schema. So this is the magic line. You need to look at this. That's the magic. Grant create schema on that catalog, on the demo catalog, to all of you. So that means in this catalog, in the demo catalog, all of you, all the account users can create their own schema. Otherwise, you couldn't do it, and otherwise you could not store your data under this catalog. But this is the schema that you're going to create if you run the pipeline, and then click on create. It's like here, it's like this one. Click on create, and it's creating the pipeline. What name did I give? I can actually click on create here. It's no problem. It's just creating one more pipeline. And then we're here, you click on start, and it's going to spin up the pipeline. I have this already. So I go back to the one that I have, which is showing up here. And that's the new one I just created. And that's the one I did very carefully. and then you click on start. It takes a while. It's actually outputting here the event log. And while it's doing that, it's starting up. So it goes from starting to running. And then at some point, this is completed. And then you see this graph. And that's what I want you to do. It might take a little bit because there's literally thousands of people now out there. Have some patience. You don't have to wait for it. I just keep talking. I'll explain you a little bit more. That's the dynamic pipeline graph. Some people, in the very beginning of DLT, we once had a customer, and this customer said to me, I don't like this idea that you draw the pipeline. And like, we're not drawing the pipeline. Who's drawing the pipeline? And this customer said, I'm like, look, the system is giving you this diagram, but the whole diagram is actually taking from the SQL code that you write. And in this SQL code, remember, we had these, go back to the SQL code because it's just here. This is the source code. Remember, we had these definitions for the streaming tables, like this streaming table and the materialized view and the next one. And then the trick is, and this gives you the connections, like if you have a raw historical loans and these other tables, and you create the silver layer tables get a new name, but they read the data from, the existing bronze layer. So this is how you connect from the bronze layer, you take a subset of the data and you filter it either by using constraints, which typically drops out the rows, or by using select, not the select star, but maybe select, column 1, column 2, column 3. And this is how you drop out the columns that you don't want. So you get rid of the rows you don't want, you get rid of the columns you don't want. You connect the bronze to the silver and the silver to the gold just by referencing them with the live keyword. And this is how at the end, in your mind, you could draw this pipeline graph, but you don't have to do it because we are doing this for you with DLT. Let me see if I can go back to here. Get this. This is actually the other thing. Once you have your notebook defined and you have your pipeline defined, it's also saying, do you want to connect to the pipeline? This notebook, do you want to connect it to the pipeline? And the answer is you can select here the pipeline that you have. So you can say, this is the pipeline I want to connect to this running pipeline. It's not working, I'm not sure. Anyway, okay, so we got the code and we got the pipeline. Let me click on Delta Live Tables again on that pipeline. I had mine running, and this is also why you see, if you zoom in, it was ingesting 22,000. Now, this is running in development mode. Development mode means it is keeping the resources up and not shutting them down. Maybe I was talking too long, but typically if those resources are up, the next run is really quick. And then if you click on start, it's not ingesting all the data again, but it's just ingesting the new loans that arrived. I'll do that, but I'm probably not waiting for this to end. You'll see it here. It says waiting for resources. And then depending on how long I was talking, maybe the resources were shut down or maybe not. But what you will see, and I can come back to this, is that you just ingest the additional number of loans that you had. So if you do it once, and then you just wait 2 minutes, and then you click this run button again, and you will see from the 22,000, it goes maybe to 26,000 in total. And that means it was only ingesting those 4,000 extra. So this is spinning up again. So I don't want you to look at this and wait all the time. The thing I wanted to show you, I think we covered the source code, we covered the pipeline view. One other cool thing I want to show you is the lineage. Again, remember, we have all the grants and these settings, and oh my God, you make me so happy, guys. Seeing all these users here, this is amazing. Just looking if there's different numbers. Yeah, that's amazing. That's so good. Excellent. Congratulations to all of you. That means you're creating these schemas and you're spinning up pipelines. That's exactly what we want. Lots of serverless pipelines. Amazing. I got distracted. What I wanted to show you is, before I got distracted, is these are the volumes. And this is my pipeline. That was the first one I created. Again, you see in the catalog, you see the tables, the streaming tables, and you see the materialized views that were created. If I click on one of them, you see more data, like you see sample data. I need to select compute first. There is a small data warehouse that we need for that. It's a serverless one, actually. I told you it's serverless, and it is a serverless one. It might take a little bit to spin up. It should take a few seconds only. While it's spinning up, there is more technical details that you can see. That's actually pretty good. There's the permission setting. Remember, I told you the SQL command to define extra. You can grant more, more permissions. You can tell people, like groups, they are allowed to select things from your table or not. You get a history of what was happening, not for the materialized views, and you get lineage. And this is what I wanted to show you. If you are on lineage and you click on the lineage diagram, you see the materialized view and the streaming table. And you say, okay, Frank, but honestly, we've seen this in the pipeline diagram. And then I'm telling you, wait, you haven't seen it all. Look at this. Then look at this. Do you see what's here? That's the volume. So the volume is a UC managed entity. And then we have the streaming table, which is a UC managed entity. So volume, streaming table, materialized view. So you get the whole, file system volume thing, data pipeline, streaming table, data pipeline, materialized view. And now it ends. This is because we are limited to 90 minutes. But think we would have a feature table, think we would have a AI model. You would see that too. So that would be here on the right-hand side. So it's AI model, it's data pipeline, and it goes back to the volume. Now, why is this extremely cool? Because ask anyone else not using such a platform with end-to-end lineage across all the system. Ask anyone else who's using a different platform about the data they use to, create the LLM. And can they technically prove where the data is coming from? Here for us, it's like super easy. We can go from the model through the pipeline backwards and then see, well, all this data is coming from the volume. And actually, if I wanted, just to show you that I'm not making jokes, this is the volume and these are the files in this volume. So I literally see the files and, I could download them or I could, use them to create a table or whatever. So they literally exist here. So that's amazing. You know what data went into your model. And then some people, they might remember the old days of data lakes, and people had this data lake, but there was actually no good system for privileges because you had to allow everyone to access everything to make the data lake work. These times are gone. You can very fine, granular define on who's able to do what with the volume. And I showed you this before. So I created this volume and you're only allowed to read from this volume. So I'm writing to the volume, the loan broker is writing to it, but you couldn't write to it. So this is like how it should be. And this is like super amazing. And you see it in Unity Catalog. Cool. That's what I wanted to show you. Now the sample data is here. Needed a second for the warehouse to spin up to deliver this data. And so you can actually see the sample data for your you also see the data type. So that's a big int and that's a string. So that's like super convenient. I always switch back and forth with Unity Catalog. I could not imagine a life without UC anymore once you got used to it. And yeah, if you got there and all these people, like all Mrs. or Mr. 1444906, you got there, congratulations. If I look at this, these are your streaming tables and materialized views. And now we have them all together because we were all like super organized and you followed what I told you. So congratulations, that's your first data pipeline running. Look at the pipeline graph, look at the lineage diagram. Another good news, and I haven't told you this yet, is you can continue to play with this for 3 days, including today. So we don't tear that environment down. It will be around for a total of 3 days. If you say, well, you liked so much the way I explained you the stuff, but you couldn't follow quickly enough, you can do this with a manual, with a lab guide tomorrow or tomorrow night or whenever you have time. If you want to play more with this, feel free to do so. The environment will stay. The GitHub repo will stay. I'm not saying forever because nothing is forever, but it will stay. And you have the slides, you get the slides, you have the lab guide. So you can just play and work with this as long as you want. You're super welcome. All right, so this was the pipeline part that I wanted to cover. And I told you a lot about serverless, and we spoke about notebooks. And what I have, and that's kind of new in this lab, is if you go to let's go to reasons here. I use this a lot because I forgot where I put stuff and I want to go back. So one trick is just click on reason and you see actually the recent tables and notebooks and volumes I was working with. So no matter what type, you just see them here listed. I want to go back to my SQL table, but I actually don't want a SQL table. What I want is this little workspace click thing. And I click here, and then I see all the other notebooks, not the SQL notebook, but all the other notebooks. And let's kick off the second one, like this one, the assistant one. And this is a notebook, and I want to use actually serverless to run the notebook. So it's connecting to serverless. It's connected now, and you see it here. It's connected to serverless. There is no cluster. I think there is a cluster. Maybe there is a cluster. I don't even know, but we're not using any cluster. That's what I promise you. And what we do is we want to run this notebook cell in serverless. Like, I don't really care how this cluster looks like. I don't want to size it. I just want to run it. I click on run. That's the triangle, or shift return. That's the shortcut for the pros. And it says, well, it says waiting, and now it's already spinning up. It says you could interrupt it. Let's give it a couple of seconds. See how this is going. That's one of the famous one-liners, and it's here. Let me click on that again. Not seeing any output. I think I'm hiding. I was hiding it. I got a little raise in my blood pressure, but I was hiding it. So it's all here. And there's this one-liner, and you say, wow, what does it do? It does display, it does Spark, it does range, it does 2DF, and then it does all these brackets. And what does it do? Well, the thing is, if you don't know what it does, you can always click here on this little assistant thing. That's a toggle for assistant. Then you get this extra command line, and then you click on dash, and then you say the second one, dash explain. Explain me what it does. The assistant pops up, and assistant is telling you what the code is doing. So lots of people talk about code generation. This is what we can do. But very often I see some code in a notebook from a colleague, who did that like 2 years ago. And I'm like, what is he doing there? I don't really get it. And then what I do is I use assistant. I say, well, /explain. It gives you this explanation, like here tells you what Spark does, what range does, and Spark.range. It generates a distributed collection of numbers from 0 to 4, not from 1 to 5, but 0 to 4. It knows all these details. It gives you super cool explanation, and then you know what's happening. And then you run it and you see what it really does. And if you run it, actually, you can also click here on performance. And now this is a silly example because this is not doing a lot. It doesn't take a lot of time, but you see the Spark statement. And if you click on this, and if it's running serverless, you get a breakdown of wall clock time, of how long it took for optimizing that query and pruning files and executing. And if you click here on query profile, you get even more. And I told you it's a silly example. It's just like this one line, but you get time spent, you get the rows, you get the memory usage. For complex examples, that's a fantastic breakdown. So this is Databricks Assistant. You can ask it questions here. You can let it explain your code. And then you can also, let's run this one. Should actually run a little bit quicker. And you see, okay, I was hiding this. It outputs this list of Python, Spark, Databricks, and the name of this is serverless. and it works pretty well. And let's assume I am missing this bracket. Okay, I run it again. And of course, it's not running. It just throws an error. And then what we could do is actually assistant pops up and it tells you what is the issue. You can define if assistant should pop up automatically or not. If it doesn't, I just close it for a minute. I can also click on this toggle assistant here and I could go to fix, just say fix. And then again, it comes up with, it knows what is missing here. It understands like my syntax problem. And I click on accept, and then it's updating the code. And then I click on run again. And it's running. Voila, it's running again. This is like if you do coding like at 2 o'clock in the morning and your eyesight is not that good anymore and your brain is a bit tired and you like, which of those brackets is missing now? Just try assistant and see if it can help you. It can very often help me. And then the other thing is docs. Who loves to write docs? Raise your hands, like virtually raise your hands. No, well, don't do it. I wouldn't see it anyway. But if you don't like to write docs, let's try this. You go here, /doc. Let's see if it can give us a meaningful explanation of what's happening here. And it can. And that's the comments, and added the comments. And hey, don't get me wrong. I'm not saying like everyone should use AI generated docs all the time. I'm not telling you should just, switch off your brain and use this all the time. I'm telling you, use this as the first version, read it, and then add your knowledge that you have, based on your use case and the circumstances on the company data, and then use it to refine. It's like 10 times easier to, to correct the first draft that you get generated with AI. And sometimes it just works, but it's not like all code should be auto-generated. It works pretty well, I would say. But use your brain. Don't make it, like an excuse to not use your brain. It's actually the opposite. Use both together. So it's assistant plus your brain should lead to a much better outcome than your brain my brain at 2 o'clock in the morning, which is just too tired and like not wanting to document code. So this is like my suggestion. Don't replace your brain power with AI, but use both together and enjoy the improved outcome. And it is an improved outcome, I tell you. It's quicker and it's better. That's the assistant. And you say, where's the assistant coming from? Well, it's actually driven by this data intelligence engine, which is not a product, where I told you it doesn't have a UI. But the data intelligence engine is learning from, well, mostly from Unity Catalog, because there we have all the metadata. And when I told you it's so cool to have a unified governance system that works for the SQL part as well as for the files part, and you've seen SQL statements already. I showed you the volumes where we have files. It works for both. The cool thing is that if you have a unified governance system like Unity Catalog, like this catalog, we also have all this metadata. And this is what we can use and, details and the permissions and feed this into this data intelligence engine and then make very clever assumptions of what people want to do. And this is when I told you, remember, this is not like a generic, somehow clever agent that is like built once. This is really based on your metadata, so based on your data. So it's kind of more not Gen AI, it's more, data intelligence based on your metadata. It's kind of metadata intelligence, yeah, don't quote me on this. I just made this up. But this is like how it works. This is like if you would not have such a unified governance system, but you would have a data lake, which you manage separately on a cloud provider, and then you have a data warehouse, which maybe is another cloud provider. And then you have an AI system where you run your TensorFlow applications. You will never have this unified governance system, And here in the data intelligence platform, we have it. We can make good use of this metadata. And this is why we can also have very clever assistants that help us to solve problems. How's everyone doing? I actually thought we'd do a break in the middle, but now we have 12 minutes left. I think like I can make it without a break. Hopefully you can also make it without a break. There's one big topic that we still should cover, and then I have some resource slides that I want to show you because we did some very cool updates recently with other demos that you can play with at Databricks, and I want to share them with you. But before we do this, you should actually say, okay, Frank, you showed us data pipelines, but you've never ever showed us a workflow. So let's do a workflow. You like to do a workflow? I think we should. How do you do a workflow? I told you this is this, what was it? Simple authoring experience. That's what we like to put on the slides. Let's see. Click on workflow. There is one workflow. I did that just to get started, but I'm not using this. And actually, I'm creating a new workflow. We click on create job. This is how we get started. Comes with this like very technical name, and I make this what's today? Thursday. Just name it Thursday. Frank. Okay, I'm breaking all the rules that I gave you. I mean, this is again, just use your user ID. I should put user underscore something. And okay, let's just, what I ask you for. Okay, this is the first workflow. You get this empty canvas. You have the first task. So this task is actually my ingest task. And that's just a task. I'm not redoing the whole pipeline. I say here, this is not a notebook. This is a DLT pipeline. And then from all the DLT pipelines, I can access, which are the two that I created. I'll take this one. So this is the task name. This is the pipeline. That's that's the type, pipeline type. That's the pipeline itself. And then I could define notifications that kind of notify my manager if something goes wrong or if this runs too long. I could define retries. I can define the triggers here. I should actually just save this first. Let me save this. So this is the first step. And then I could go and say, let's add a trigger. And I can go and say, this should be scheduled, file arrival continuous. I can define parameters for this workflow, notifications, etc. Okay. So what I wanted to do is I wanted to add a second task. Like just one task is a bit boring. I add a second task. It's a notebook task. And you see, wow, they're already connected. Isn't that cool? And that second task, it's a kind of like hello world task. It's a little bit artificial. It's like the smallest notebook that I could put together. So this is like in my mind, I want to use this task to notify a downstream system. And just imagine you run the first task and then you have to notify another system. You maybe do an API call, something you want to code in a notebook. It is a notebook. It's in the workspace. It is actually here, username, TMM. You know this game already, Pipelines Workshop. And then it's look at this, update downstream system. Click on this. We have a workflow now. And oops, unsave changes. Let me save this. And if I select that task, you also see compute equals serverless. So I don't need to define a cluster. It's running serverless. Remember, I told you actually everything is running serverless in the Lakehouse these days. The ingest pipeline, well, it's just using the pipeline that I defined. I don't even need to define serverless because in the pipeline definition, I defined serverless. But that task, it's a notebook. Where should it run the notebook? The answer is, well, just use serverless. I don't really want to deal with these compute things. You see, my like the things I want to think about is how do I build those workflows? But don't ask me about that compute. Click on run now. And remember that DLT pipeline, it was triggered. So if I run the workflow, it will run the pipeline. The pipeline is a triggered pipeline. It will do something and then stop, and then it will go to this task. Let's try this. Might take a while because, again, there's like thousands of people out there. And does it do something? Well, if I click on run here, you say, oh, it's blinking. It's starting up. That's cool. That's very good. So this is the total time it needs to run the workflow. This is for the first task, and this is for the second task. And you see all this under job runs. And this is the, look at this. This is like my test pipeline, and that's the one I just built. So you see all of them together. This is like the global view. And then I can actually click on this one, which is running right now. And you see this is running. It's, you see it's retaining. It's still, this one is not doing something. And I absolutely love this view. Look at this. This is the timeline view. It's like a Gantt diagram. So you see these horizontal bars that express the length of this run. And well, there's not much happening because this is still blocked for this one. They're not running in parallel. It's one after the other. And you would see that this one is then started once this one is finished. If you have a task here, and I was actually showing this in one of the resources I'm going to show you in just 2 minutes. If you have a SQL task here, you can break this down. You see the individual SQL statements that are happening in this notebook, and then you can also drill down and go into query execution and see how long these queries took. A little bit like what I showed you for this performance link that we did in the other notebook. So this is going on, just takes as long as this ingestion is taking, and then it's going to run that second task. And actually, we can wait a little bit. You get your exit poll already, which is also fine. Not planning to run over a lot, which is also kind of a new thing. We used to be really bad in timekeeping, and now we're getting better at this. So this just takes a little bit. I told you. I actually wanted to show you what happens next. You guessed this is getting green, and then we're done. And the answer is, well, not really, because, and I go back to another job run. Let me go back to this one. And you see, well, here something happened. Like I can actually tell you what happened. I triggered this workflow, and then I saw the pipeline running, and I forgot that I triggered the workflow, and then I stopped the pipeline. So the whole thing failed at the end because I stopped it in the middle. What could happen is that just this last task fails. And it's actually quite likely that this last task is failing. Don't remember how I checked it into GitHub, but what I did here is something like super mean. You know, this is like to test you. So we have this raise statement that raises an exception. And the whole thing that the second task is doing is running this notebook, and then we use it to play with all kind of things. Sometimes I add a random delay, but this one is just stopping and raising an error. So if you go back to, to that run, that one would not be green, it would be red. And if you go to graph, you would see this as red as well. And in the matrix view, I like this matrix, the last one would turn red. And then if the last one is turning red, you can click on this. Now, this had another reason. But if you click on this, you would see the error message. Now, this one is like, because I stopped it, I told you that was me being stupid. Don't be me, don't be stupid. But if you have this, you can click on the notebook. You can fix the issue. And then once you fix the issue in the notebook, you can go back, and then you click on this repair task. Now, this repair task, you can either, well, you can select the tasks that you want to run. So typically it's only like if this one was green already, but this one is red, you had the problem here, and you would select this one. So you can select individual tasks that you choose, or you can use all of them downstreams from the problem. And then if you do this, and actually I've never done that, like this one was a little bit artificial because I caused it. But then if you click on repair run, it would do a repair run, which is then spinning up. And this might take a little bit, but then they should turn green. So what typically happens if you go to job runs, and we go to job run, let me go there again. Let me go to this one, timeline. Well, the thing, like the one that was red is executing again, and it turns green. So it's not rerunning a complete new workflow. It's just rerunning what needs to be rerun. And in the matrix diagram, you would see this as turning green. All right, try it. I think you remember it was like actually really easy putting this together. What I did is I created this task. You basically click on add task and then you select any of these. And it could be a dashboard refresh. It could be DLT. There's this open source DBT. You could run a DBT project. You actually could run from a workflow another job. That means it's another workflow. So you can cascade them or concatenate, depending on how you want to view that. And you can have modular workflows, and one is triggered like another workflow module. We can have if-else conditions. We can have for each. And you say, okay, but you're not showing us this. And the reason is we have 1 minute left. I'm not showing you all of these tasks, but I give you some resources where you can see these tasks. And these resources are one, like a super cool resource. We just redid this. If you say, well, I liked your DLT example, but I want to see another one. I'm not convinced yet. But I also like, I want some guidance. I want a step-by-step tutorial. Go to this DLT Getting Started guide. Once you have the slides, just click here on this. This is the link, easy to follow step-by-step tutorial. It takes you step-by-step through another example. If I click here, you see it. And this is actually even giving you the code. So, I mean, it says here optional. If you know about how to work with GitHub, that's all of you now. Clone this repo and you say, oh, come on, Frank, that's the same repo, isn't it? But we use another folder and it's the New York Taxi Fares folder. So the example that I'm giving you here, and I actually built that. So if something is not like, if you're not happy with the taxi trips, you can, well, you know who to blame with. So what is happening here is we ingest like, I don't know how many, I think it says somewhere, I think it's hundreds of thousands of New York taxi trips. And then we look for the ones that either don't cross the zip code, so they stay within a tiny part of New York, or which are incredibly expensive. So we look for the super expensive ones, like small distance and a huge amount of money that you paid. And I think I found one that cost $90, and the guy was like guy or woman was riding less than 1 mile. So this is what this example is doing. And you get a step-by-step. Remember this, create pipeline, put in the name, click on serverless, leave it to triggered. That's all what you did. If you want to redo it with another example, Google Databricks DLT Getting Started Guide, or click on the link once you have the slides. I'm biased. I build it. It gives you the top N of the really bad taxi rides. You don't want to be in this top N. It's where people paid a lot of money for a super short distance. It's a fun thing to do. It's also a fun thing to do if you want to send this to a friend who's starting with DLT. I recommend this. There's another one. I did a session at the Data and AI Summit, and that was a fun session. It's actually related to DLT. And I told you DLT can also ingest streaming data from Kafka. And then now you say, okay, Frank, I would like to see a Kafka example. And I tell you what, honestly, Kafka examples are hard because like, where's Kafka? Like if I set up a Kafka server and you do that like next week, you don't have that Kafka server. And then like, do you know any public Kafka server out there in the world? And the answer is no. Well, the answer is not no anymore because there is one. And I'm showing you how to use this one. Actually, this one public Kafka server that I know of, it's like a super cool one. It's one that NASA offers. And it's actually one where NASA puts satellite data. They observe supernovas and black holes. And whenever they spot something, they put a message about this spotted event, like a supernova or black hole, into a Kafka topic. And if you know how to connect to the topic, I'll teach you in that blog, and that there's a repo also with it. You just read from the topic. Now, the message in that topic, it says, at this coordinate, something happened, and it has this merit value. Now, there's thousands of telescopes on Earth reading from that topic, but you can do the same thing. It's a public topic. And I give you the code. You can read that code, and you see these messages coming from actually satellites telling the biggest telescopes on Earth that if the merit value is high enough, they could rotate to some location and observe a supernova that is just, I never know, do they explode or implode? whatever. I mean, I recommend this. It's a fun story. It's comes with the source code. What is the pipeline doing? It's doing STs and MVs. So you're now very well prepared to run this if you want. The link is there. The GitHub is there. If you say, well, I'm the biggest fan of workflows now, I would like to see another cool workflow example that is a little bit more than just your 2 tasks. Click on this, and it takes you to the Databricks demo center. It's databricks.com/demos. I recorded a demo, and in this demo, sorry, you hear my voice, and in this demo, we have a DLT pipeline that looks like this. It's using the cookies data set that we introduced at Data and AI Summit. So it's using a cookies franchise, cookie franchise, that's the word now. And it's ingesting data that is coming from a managed connector from SQL Server. And it's also ingesting data that is coming from Salesforce. So from Salesforce, it's taking the franchises that exist. It's ingesting, I think, 30,000 transactions from people buying cookies. And then it's kind of joining the data. It also knows about suppliers that exist. It's an XML data set that is ingested. Yeah, with autoloader, this is how we read, files. And then it's combining all this data. It's calculating the top 5 locations where you could build a new bakehouse flagship store. And, well, this is just a DLT pipeline, but it's also running a workflow. First step is the ingestion pipeline. Second step is a little bit artificial. We decide if we should use the AI. If that is true, we do a SQL statement. And in that SQL statement, we do a call out to an LLM. And just shifting forward. And look, this is the really cool timeline that you get if you have like SQL statements in your task. You can break it down to the tiniest amount of execution time. And then we actually even show you how to run this as a Databricks asset bundle. That's a way to deploy your whole project with a workflow and a DLT and a SQL task. And it's basically it's basically doing Databricks bundle, and then you generate it, and then later you say Databricks bundle deploy. And then at the very end, let's see if I can find this here on YouTube. It's too short. Where is it? Damn, that's the very last thing I wanted to show you. No, my motorics are not. This is it. No, it's not. Come on. I have it at the beginning as well. Guys, give me one more. This is it. Okay. At the very end, what it does is it's using that data and the top 5 locations based on sales numbers. It knows the city, it knows the local ingredients, all coming from different data sources. And then it uses the SQL call out to generate a description of the new flagship store. And don't get me wrong, we're not using some hallucinating LLM to decide where we should build a $20 million flagship store. This is all done on real data. This is streaming live data that we have in the first columns. But then once we know the flagship store should be in LA and it should be in Silver Lake. I've never been to Silver Lake, but I hope it makes sense. Then we can tell the LLM, if we have a flagship store in LA, where the local ingredients are pecans and the flagship store is here in Silver Lake, it should have the following description. That description is derived with the LLM. And here we have one. If you've ever went for a swim in Sydney, Australia, it might be Bondi Beach. And that's the way the Bondi Beach flagship store could look like as imagined by the LLM. So hard facts for the location and for where we should build it, streaming data, and then, okay, before I build it, give me a description of how would that look like. And it's telling you, Bondi Beach, Sydney, must visit destination. It gives you the sales brochure, basically. And this is where you see the true beauty of, combining things in a workflow. And the workflow is triggering the pipeline. And then in the next step, we do this SQL call out. And that's the very last thing. All these resources, again, we have them in the in the slides that we share with you. You have the GitHub, you have the lab guide. The environment is going to stay up for 3 days in total. At this point, I want to thank my fantastic colleagues who were working in the background, probably working a lot while I was just talking, helping you with all your questions. I hope you enjoyed it. Thank you for being here. Thank you to my colleagues. Thank you to the organizers. And if you have friends and colleagues who are interested, we run this every quarter. It's like once a quarter. There will be another webinar that we do where you don't work hands-on. That will be in November. If you follow me on LinkedIn, I will share it there for sure. Actually, I plan to use this demo, like this demo I want to show in the webinar. I'm going to give you more details about the asset bundle and another cool thing that I want to do for the first time ever in a webinar. It's not official, but I'm telling you, because like, just keep it as a secret. We want to get the data from Marketplace. So what we have in Databricks, we have something which is called Marketplace. And in Marketplace, see if that's working. Oh my God, look at this. This is brand new. I've never tried that before. In Marketplace, we have data sets, and you can ask, you can get your data sets onto Marketplace and share them with cost or without cost. You can share them privately. It could be a private exchange, but this cookie data set that I just told you, it's on Marketplace. It's not the final version, so don't tell anyone yet. But it will be the final version like next week. And we kick off with this cookie data set. So everyone who wants to redo the thing goes to the data set. You just get it from Marketplace. You click on it. And then here takes a second, get instant access. And then you say, I'm happy with all these rules. Get me the thing. And it shows up in Unity Catalog. This looks like magic. I absolutely love it. We're going to show you the first time with this live cookie data set in the November webinar. And then from that time on, you can always use this cookie data set. Isn't that cool? All right. I already said thank you. I already said goodbye. See you again. Bye-bye.